All right, we're going to do this super duper quick little discrete random variable information so that you can finish up units 1 through 5. All right, so this is the only part of that the formula chart we haven't talked about on the front page. Okay, so we've got this discrete random variables. Remember, discrete random variables are things where you have a finite amount of items that could occur. For example, and I'm going to show it to you here on my calculator. What if we had different amounts of people? There was either going to be a game with 28 people, or there was going to be a game with 65 people, or there's going to be a game with 12 people. Maybe these are different kinds of games. Well, the games with 28 people happen 2% of the time, or 20%, sorry, and the games with 65 people happens 50% of the time. So a lot of the time they need that. And the games with 12 people, 30%. Okay. So you have 3 discrete options, and they happen this frequently amount of time. So if we wanted to find, on average, how many people are we going to need to play a game on any given day? So we would then want the mean and the standard deviation of this probability distribution. Notice that the probabilities all add up to 100%. That has to happen. If something's missing, then you know there's another value here, that would have some probability, because this has 100% of the discrete options. All right, then you're going to do your stat calc, your one variable statistics of list 1, again, with list 2's frequency. And so, you do second number 2 there. And then you calculate. So what this tells me then, on average, I need to have about 41.7 people show up in order to play any one of those, the games on those given days. Okay? And then look at the standard deviation. The reason the population standard deviation is the one that shows up, and only that, is because our data was 100%. That was the population. So we don't have this sample standard deviation. Okay, so here's the variability in how many people we need for the game, or whatever this problem was about. Okay, and that's what it says here. To find that expected value with that probability, you can do that. Now, transformations. We know that we have addressed a lot where the center is our addition and subtraction only is affecting the center where the data is located. Okay. If you multiply and divide all the pieces of data, of course, that's going to change where the center is located and the spread. Now, look, transformations are not changing that general shape of the distribution of data. We hadn't really talked about that much, but I like that that brings that here. All right. And then the final topic, what if we are combining random variables? So, for example, the amount of allowance that my brother got in a week and the amount of allowance that I got in a week varied. So that was a variable, okay? And so he got so much on average with the standard deviation. I got so much on average with the standard deviation. And it depended on chores, okay? It varied based on how many chores we had done that week. So now, if we are just seeing, what do my parents have to pay in allowance fees? Well, if I'm adding or subtracting, those means can add or subtract like normal. But remember that standard deviation has special rules. You have to do that Pythagorean theorem of statistics. The variability in combining our allowances together was not just his standard deviation plus my standard deviation. Nope. You had to do this standard deviation of his squared plus standard deviation of mine squared, and then square rooted. That Pythagorean theorem of statistics. And finally, one other thing to remember is that whether I was finding the difference between our allowances. I was subtracting, so that's this second picture here. Or if I was combining, the means would subtract if I was finding the difference. But look, that standard deviation is still gonna get bigger. I wasn't sure how much he was getting. I'm not sure how much I'm getting. So the difference between them is still very, even more unknown. How much is the difference between them is even more uncertain. So that's why we still add. All right, so that's the basics of your combining random variables and transforming them. So I'm going to go ahead and let you then practice your problems based on the discrete random variables.